Let us discuss some of the questions related to the chapter Real Numbers. So, express, first question, that is, express 156 as a product of prime factors. Okay, so let us take this 156. First prime, that is 2. Let us start by 2. Here it ends with 6. So, thus divisible by 2. So, 2 sevens are 14. 1 is remaining 16. 2 eights are 16. Again, it can be divisible by 2. That is, 2 threes are 6. 1 is remaining 18. 2 nines are 18. It ends with 9. 39 here ends with 9. So, it is not divisible by 2. So, let us take 3. 3 ones are 3. 3 threes are 9. We know that this 13 is a prime number. So, we can write 156 as a product of primes, that is 2 into 2 into 3 into 13. So, here 2 comes 2 times, that is 2 power 2 into 3 into 13. Here we have written 156 as a product of primes. Next question. Find the HCF and LCM of a given pair of integers. We have to find HCF and LCM of a given pair of integers, and we have to verify the relationship. What is that? HCF into LCM is nothing but the product of two integers. Okay, we have to find the HCF and LCM of a given two pair of integers, and we have to prove this HCF into LCM is equal to product of that two integers. Here let us take smaller one, that is 26 and 91. 26 here factorize 26, it is ends with 6, so it is divisible by 2. 2 ones are 2, 2 threes are 6. 13, 13 we know that is a prime number. It is not divisible by any other number. Next is 91. 91 is not divisible by 2. 3 also not possible. Correct? Here ends with 1. See here, 3 threes are 9. Correct? 1, it's remaining. It's not possible. So it is divisible by 7. 7, 13 is a 91. 13 is a prime number. So as a product of primes, we can write it as 26 is equal to 2 into 13 and 91 as 7 into 13. All powers are 1 here. Correct? And next we have to find HCF. HCF of this 26 into 91. HCF means nothing but what is that? The product of smallest power of each common prime factor in the numbers. So here common in this 26 and 91, the primes are 13, correct? And its least smallest power is 1. That's why the highest common factor of this 26 and 91 is 13 power 1, that is 30. And LCM of least common multiple of this 26 and 91, that is what? The product of greatest power. Here they are, here we should not take the common, correct? So whatever the primes are there, we have to write that 2 into 7 into 13. All powers, highest power. It is nothing but 1 only. So we will write 1 as it is. Next, 2 power 1 is 2, 7 power 1 is 7, 13 power is 13. 2 sevens are 40 into 13. 13 fours are nothing but that is 52 is 5, and 13 ones are 13. 13 ones are 13 plus 5. It is 18. Correct? Therefore, LCM of that this two numbers is 182. HCF, we have to now verify. HCF into LCM. HCF into LCM, that is HCF we got, that is 30. LCM is 182. 13 into 182. 13 twos are 26. 2. 13 is 8s are 2, that is 106. 10 is remaining. 13 ones are 13. 13 ones are 13 plus 10, that is 23. So 2366 is the HCF into LCM. Then we have to take the product of that two integers. We took two integers, that is 26 into 91. Here let us multiply 26 into 91. 1 6 are 6, 1 2 are 2, 9 6 are 54, 5, 9 2 are 18, 23. Here 6, 4 plus 2, that is 6, 3, 2. So answer is 2366. Verify, we have to write HCF into LCM is equal to A into B. Correct? HCF of A and B, that is 13 into LCM of that 26 and 91, that is 182 into is equal to 26 into 91. 13 into 182, nothing but we got here, that is 2366 is equal to 2000. Correct? We have verified this HCF into LCM is equal to the product of two integers. Next, third question. By the prime factorization method, find the HCF and LCM of 8, 9, 25 by prime factorization method. Okay, by the prime factorization method, we have to find the HCF and LCM of given numbers. Okay. Here 8 they have given. Let us factorize. 2 3s are 2 4s are 8. 2 2s are 4. Here 2 is a prime. So 8, then let us take 9. Next number 3. 3s are 9. 3 is prime. Next 25. 5. 5 is a 25. 5 is a prime. So 8 can be written as the product of primes. That is 8 is equal to 2 into 2 into 2. So 2 times, and 9 can be written as a 3 into 3, that is 3 power 2. Then 25 is equal to 5 into 5, 5 2 times. Can write this HCF of 8, 9, 25. What is that? Nothing but we have to look into the common primes. What is that? Here nothing is common. Here 2 is there, here 3 is there, here 5 is there, correct? So nothing is common, that's why HCF is 1. Then LCM, least common multiplier of this 8, 9, 25. What is that? What and all prime is there? We will write that first. 2 is there, 3 is there, and 5 is there. Then highest power. Highest power here is 3, here is 2, and again here is 2. If possible, you can simplify this. 8 into 9 into 25. 2 into 25. You can stop here. Okay. Okay, stop. I hope you understood this. If you have any doubts, please put up comment section. Thank you for watching.